A visitor from outside our solar system has slipped in, and almost no one saw it coming. The object now known as 3I Atlas wasn't predicted, wasn't tracked early, and arrived at a moment when the usual flow of data from NASA was slowed. Astronomers rushed to confirm its path, while lawmakers wondered why an interstellar object could appear with so little public information attached to it. Nothing about 3I Atlas suggests danger, but its timing and odd behavior have raised real questions. How did this object surprise the people who watch the sky for a living, and what does it reveal about the limits of our current monitoring systems? 3I Atlas is the third object ever confirmed to come from outside our solar system. The discovery came from a survey telescope that routinely scans the sky for anything that moves in an unexpected way. At first it looked like a faint, slow-shifting point of light, the kind that could easily blend in with the background. Once its motion was measured over a few nights, the orbit calculation showed something you don't see with normal comets. Instead of looping around the sun, its path was open. That meant it wasn't bound to our star at all. It was simply passing through. It behaves enough like a comet that astronomers classify it as one, but it doesn't match the common patterns seen in icy bodies that formed near us. Its brightness rises and fades in a way that hints at a different mix of frozen material. Some early measurements suggest it releases more carbon dioxide than most local comets, which points to a very cold place of origin. That aligns with the idea that it formed around another star in a region far from the heat and pressure of its home system. Its trajectory through the solar system is steep and fast. It's moving quicker than most bodies we track, which makes sense because it isn't trapped by the sun's gravity. It's swept in on a hyperbolic route and will head back into interstellar space once it clears the inner system. Because of that speed, every chance to observe it matters. Telescopes only get a short window to measure its composition, rotation, and surface activity before it fades from reach. So 3I Atlas is a visitor that won't return. It's a brief look at material shaped around another star, drifting past us on a path we didn't expect to catch in time. The surprise didn't come from the object itself. It came from the timing. 3I Atlas was first flagged during a period when several NASA divisions were still working through delays from the early year funding pause. That slowdown meant new observations and processed images were moving through the system more slowly than usual. Astronomers outside NASA could see that an unusual object had been logged, but the official data products that normally appear quickly took longer to show up. By the time orbit calculations confirmed its interstellar origin, the information gap had become noticeable. Members of Congress who follow space programs were caught off guard when outside researchers began talking about an object that wasn't yet fully documented through NASA's usual channels. That created the impression that something significant had been spotted without the government being promptly informed, which led to pointed questions about how interstellar detections are handled during administrative delays. Inside NASA, the surprise was more practical. Most incoming objects are routine, so anything that looks unusual depends on timely confirmation. With 3I Atlas, those checks lined up with a period when staffing and review cycles were stretched. No one expected the third known interstellar object to appear in the middle of a backlog. The result was a moment where an important discovery had outrun the communication pipeline. Nothing was hidden, but the schedule mismatch made it look that way. For lawmakers, that raised concerns about whether other rare events could slip through unnoticed during bureaucratic slowdowns. For scientists, it highlighted how much depends on steady, uninterrupted monitoring. 3I Atlas showed that even in a sky filled with predictable motion, timing can still be the biggest surprise of all. 3I Atlas gives scientists a chance to see what small bodies look like in other planetary systems, and even early observations hint that it isn't shaped by the same conditions as local comets. Its spectrum points to a mix of ices that reacts differently to sunlight. The release of carbon dioxide appears stronger than average, which suggests it spent most of its life in a colder, darker region than anything found around our Sun. That alone makes it interesting because it hints at chemistry shaped in a very distant environment. The way it brightens also stands out. Typical comets show a steady change as they warm, but this one shows sharper shifts that might come from uneven pockets of volatile material near its surface. That pattern raises questions about how it formed and how long it drifted through interstellar space before reaching us. Some astronomers think that long journey may have roughened its exterior, leaving a crust that hides fresher ice beneath. Its path through the solar system adds another puzzle. The angle of approach is steep compared to most interstellar objects we've modelled. That doesn't imply anything exotic, but it means it passed through regions of its home system very different from where long-period comets form around the Sun. The trajectory also gives a hint about its speed relative to the Sun, which suggests it wasn't flung out by a recent violent event, but instead has been coasting between stars for a long time. All these pieces matter because we have so few examples to compare. Oumuamua and Borisov gave us a starting point, but 3I Atlas behaves differently enough that it pushes scientists to refine their models of how material moves between stars. Each measurement helps build a clearer picture of what young planetary systems might produce, and how those fragments travel across the galaxy long before anyone is around to notice. 3I Atlas is already moving away from the inner solar system, which means the next stretch of observations will focus on getting as much detail as possible before it fades from reach. Ground telescopes will keep tracking its brightness and rotation, while larger observatories measure any lingering gas or dust around it. These last readings help scientists pin down how its surface responds to sunlight and how quickly its activity changes as it cools again. The goal now is to collect enough measurements to link its behavior to a place of origin. Every comet carries clues about the temperature, pressure, and chemistry of the region where it formed. Because 3I Atlas comes from another star, even small details can reveal what other planetary systems might be like. If its ice mixture leans heavily toward carbon dioxide, for example, that suggests its home system has colder outer regions or a different distribution of volatile material than ours. Researchers are also using its path to refine the search methods that find interstellar objects in the first place. The fact that 3I Atlas appeared during a period of delayed processing made it clear that rare events can slip by if the timing isn't ideal. Improving automated alerts, streamlining data review, and coordinating observations across different facilities will help make the next detection smoother. For the public, 3I Atlas will probably disappear from view within months, but the science continues long after it's gone. The data collected now will feed into models that describe how fragments of distant worlds travel across the galaxy. Each interstellar visitor shows a different piece of that story, and this one adds a new set of clues about how material moves between stars. 3I Atlas arrived quietly, yet it revealed how even well-prepared systems can be caught off balance. A single object from deep space exposed gaps in timing, communication, and assumptions about how quickly unusual discoveries should be shared. It also offered a reminder that our solar system is not isolated. Every so often, something built around another star passes close enough for us to study, and we get a brief look at a place we may never see again. Moments like this help keep science honest. They show where our tools work well and where they need refining. They also show how much more there is to learn about the worlds that form far from our own. As 3I Atlas fades back into the dark, it leaves behind data that will shape how we watch the sky for years.